This notebook presents how to distinguish the relative importance of the features in the dataset. It is particularly useful in our feature engineering because we can concentrate on variables that really have some importance and remove those completely redundant. Our plan is to load libraries in the data, train a model, then learn how a single tree is represented in XGBoost package, and finally plot feature importance. So let's proceed with loading the libraries. The first code cell is responsible for importing all the required dependencies. As you can see, we are using native XGBoost library. Then we are going to load some data. In the second code cell, we are executing the dmatrix object and passing to it a file containing both training and testing datasets. Now we can train the model. Because of the demonstration purposes, we will create the ensemble consisting of 5 decision tree stems solving binary logistic problem. They will not output any errors or messages, so we are setting silent parameter, and we'll learn at a very average learning rate. While training the model, it is also useful to create a watchlist object, which is an array of both testing and training dataset. Then you can train the classifier by passing all the required parameters. In the output, you can see that the algorithm is actually learning something. Both for testing and training dataset, the error is getting lower for each tree. Now, let's see how a tree is represented inside an algorithm. The model of the algorithm created by the XGBoost package contains the getDump function, which is capable of extracting all statistics for each tree. We can execute it and print the information for each classifier. Let's analyze the output by concentrating on the first tree. As you can see, it has made a split based on the odor equals pungent feature. There are 2 possible choices, yes or no. Yes goes to the leaf number 2, no goes to the leaf number 1. And there are 2 other informations like gain and cover. Gain measures the actual improvement in accuracy brought by that feature, and cover measures the relative quantity of observations concerned by it. So, by analyzing the value of the gain for each feature can help us to measure its importance. Let's try to plot it. There is a built-in function called plot importance, which expects at least one argument, an estimator. But here we are passing another one, important type equals gain. On the plot, you can see a gain introduced by a feature with a specific number. You can see that the 29th feature, which is odor equals pungent, seems to be the most important. We can simplify things a little bit by introducing a F-score metric, which simply sums how many times a split was performed on each feature. The same function as before, executed without additional parameters, plots the F-score chart. In case we don't like the stock plots generated by the XGBoost package, we can do our own by obtaining the dictionary of the F-scores and creating our own custom charts, for example like this. In summary, both gain and F-score can be used to distinguish which features take part in creation of the trees and are worth further investigating.